Rules. The central strategy proof rule on this domain is the simple median voter rule. Suppose that the number of agents n is odd. Then the rule that picks the median of the agents picks, PIs, is a strategy proof rule. It is straightforward to see why this rule is strategy proof. If an agent's pick PI lies below the median pick, then he can change the median only by reporting a preference relation whose pick lies above the true median. The effect of this misreport is for the rule to choose a point even further away from PI, making the agent worse off. A symmetric argument handles the case in which the pick is above the median. Finally, an agent cannot profitably misreport his preferences if his pick is the median one to begin with. More generally, for any number of agents n and any positive integer k which is less than or equals to n, the rule that picks the kth highest pick is strategy proof for precisely the same reasons as above. An agent can only move the kth pick further from his own. The median happens to be the case where k equals to n plus 1 over 2. The strategy proofness of such rules stands in contrast to the incentives properties of rules that choose average-type statistics. Consider the rule that chooses the average of the n agents' picks. Any agent with pick pi which is in the open interval between 0 and 1 that is not equal to the average can manipulate the rule by reporting preferences with a more extreme peak, closer to 0 or 1 than his true peak. This would also hold for any weighted average of the agent's peaks, with one exception. If a rule allocated all of the weight to one agent, then the resulting rule simply picks that agent's pick always. Such a dictatorial rule is strategy proof and onto. In addition to favorable incentives properties, rules based on order statistics have the property that they require little information to be computed. Technically, a rule requires agents to report an entire preference ordering over the unit interval. The rules we have discussed so far, however, only require agents to report their most preferred point, i.e. a single number. In fact, under the onto assumption, this information property is a consequence of the strategy proofness requirement. That is, all strategy proof and onto rules have the property that they can be computed solely from information about the agent's picks. To begin showing this, we first observe that the class of kth statistic rules can be further generalized as follows. Consider a fixed set of points y1, y2, y3, and so on until yn minus 1 in A. Consider the rule that for any profile of preferences greater than equals to chooses the median of the two n minus 1 points consisting of the n agent's picks and the n minus 1 points of y. This kind of rule differs from the previous ones in that for some choices of y and some profiles of preferences, the rule may choose a point that is not the peak of any agent's preferences. Yet, for the same reasons above, such a rule is strategy proof. It turns out that such rules composes the entire class of strategy proof and onto rules that treat agents symmetrically. To formalize these later requirements, we call a rule anonymous if for any greater than equals to in R to the n and any permutation greater than equals to prime of greater than equals to f of greater than equals to prime equals to f of greater than equals to. This requirement captures the idea that the agent's names play no role in the behavior of a rule. Dictatorial rules mentioned above are examples of rules that are strategy-proof and onto, but not anonymous. Theorem 10.2. A rule F is strategy-proof, onto, and anonymous if and only if there exists y1, y2, and so on, yn-1, all of them is in the unit interval such that for all greater than equals to in R to the n, f of greater than equals to is equals to the median of the following set, containing the element p1, p2, and so on until pn, y1, y2, and so on until yn-1. The parameters yn's in theorem 10.2 can be thought of as the rule's degree of compromise when agents have extremist preferences. If m agents prefer the highest possible outcome, while n-m prefer the lowest, that is 0, the highest is 1, then which point should be chosen? The true median rule would pick whichever extreme, 0 or 1, contains the most peaks. On the other hand, the other rules described in the theorem may choose intermediate points ym as a compromise. The degree of compromise which ym can depend on the degree to which the agent's opinions are divided, the size of n. The anonymity requirement is a natural one in situations where agents are to be treated as equals. If one does not require this, however, the class of strategy-proof rules becomes even larger. We have already mentioned dictatorial rules, which always chooses a predetermined agent's pick. There are less extreme violations of anonymity. The full class of strategy-proof onto rules, which we now define, allows agents to be treated with varying degrees of asymmetry. Definition 10.3. A rule F is a generalized median voter scheme, GMVS, generalized median voter scheme, if there exist 2 to the n points in the unit interval, and the set alpha s such that s is subset equals to n, such that the following three holds. 1. S is less than equals to is a subset equals to t, which is a subset equals to n, implies that alpha s is less than equals to alpha t. 2. Alpha empty set equals to 0, alpha n equals to 1. And 3. For all greater than equals to in R to the n, f of greater than equals to is the max mean, where the outer maxima is taken between all s, which is a subset of n, and the inner minima is chosen among the set alpha s and pi such that I is in S. An example is given below. It is worth making two observations regarding definition 10.3. First, the monotonicity condition 1 is actually redundant if parameters the set alpha s such that s, which is a subset equals to n, fail this condition. They still define some strategy-proof rule via condition 3. However, the resulting rule could also be defined by an alternate set of parameters. The set alpha s prime such that s is a subset equals to n that do satisfy condition 1. Second, condition 2 is present merely to guarantee the rule to be onto. Parameters that fail this condition still define a strategy-proof rule whose range is the closed interval between alpha empty set and alpha n. Consider the rule described by the parameters alpha s in figure 10.2 for the 3-agent case. The reader should first verify the following. if each agent in some set S, which is a subset equals to n, were to have a preference peak at 1, while each remaining agent in n over S were to have a preference peak at 0, then the rule would choose alpha S as the outcome. In this sense, the alpha S parameters reflect an anonymous degree of compromise at extreme preference profiles, analogous to the Ym parameters of theorem 10.2. Without the anonymity condition, some agents, or generally some coalitions of agents, are more powerful than others. To see this, consider the profile of preferences represented in figure 10.2, with peaks P1, P2, P3. Following condition 3 of definition 10.3, calculate the minima of the set of alpha S and Pi such that I is in S for each S which is a subset equals to n. Beginning with the three singleton coalitions of the form S, which is a set of I, these values are alpha 1, alpha 2, and alpha 3 because each Pi is above that agent's corresponding alpha, the set of I. For peak P3 prime, the third value would have been P3 prime instead, since the GMVS eventually chooses the maximum of these kinds of values after we also check larger coalitions. Agent 3 can be said to have more power than the other two agents as a singleton. A large alpha 3 corresponds to more instances in which agent 3's peak is an candidate outcome for this rule. A small alpha 1 corresponds to more instances in which agent 1 has no impact on the outcome, i.e. whenever P1 is greater than alpha of the set of 1. On the other hand, we also need to calculate these minimum values for larger coalitions for the pairs of agents 1, 2, 1, 3, and 2, 3. These values are alpha, the set of 1, 2, P1, and P2 respectively. Coalition, the set of 1, 2, is the weakest two-agent coalition in the sense that they have the lowest alpha S. After checking S, which is an empty set, which yields 0, and S equals to n, yielding a repetition of the value P2, we calculate the rule's outcome to be the maximum of the 2 to the n values. 0, alpha 1, alpha 2, alpha 3, alpha of the set 1, 2, P1, P2. We have obtained, which is alpha, the set of 3. We close by stating the main result of this section. We omit its proof, which has much in common with the proof of theorem 10.2. Theorem 10.4, a rule F is strategy proof and onto if and only if it is a generalized median voter scheme.